Born in wartime as a strategic food source, condensed milk has journeyed through more than a century to become the soul of millions of desserts while fueling a multi-billion-dollar industry. But how are millions of tons of condensed milk produced every year? From lush dairy farms, where pure white milk is collected from healthy, well-cared-for cows, the fresh milk travels to massive factories. There, advanced technology and centuries of expertise transform it into smooth, sweet, and nutrient-rich cans of condensed milk, ready to reach every corner of the globe. Today, join Agriculture Insight as we uncover the entire journey behind each can of this white gold and reveal the secrets that have made condensed milk an enduring legend for hundreds of years. Everything will be revealed in this video. Before the 19th century, when refrigeration was still a distant dream, preserving fresh milk was nearly impossible. Until 1856, when American inventor Gail Borden, driven by a sweet mission, created the secret formula that allowed milk to be stored for years in tin cans without cooling, opening the door to an industry now worth over $10 billion USD. Once a strategic ration in world wars, condensed milk today crowns the United States as the global leader with more than 700,000 tons produced annually by giants like Nestlé and Borden Dairy, while the Netherlands holds the title of the heart of Europe, combining large-scale production with a role as a global export hub. Compared to perishable fresh milk, condensed milk stands out for its long shelf life and affordability, while still retaining essential proteins, calcium, and vitamins. Yet, with its high sugar content, it remains both a vital energy bomb in times of scarcity and a product requiring moderation in modern diets. And like every great journey, it all begins at the source. Let us return to the very birthplace of billions of cans of condensed milk, the dairy farm, where the story starts with the harvest of pure, fresh milk. But do you know how to create rich and nutritious drops of milk? The secret lies in the cow's diet, which starts with lush green pastures, a plentiful source of nutrients that keeps the cows healthy and helps them produce high-quality milk. Out in the vast fields, specialized grass-cutting machines work tirelessly, slicing through rows of grass with precision and efficiency. These machines can mow dozens of hectares of grass per hour, cutting it evenly and at the right height to allow for quick regrowth. After the grass is harvested and ensiled, ensuring high-quality milk begins with prioritizing the health and comfort of dairy cows, with nutrition remaining the most critical factor. Their diet is carefully formulated to balance hay, silage corn, straw, and energy-rich grains, supplemented with soybeans, minerals, and vitamins. All of these ingredients are blended in a total mixed ration machine to guarantee that every cow receives the nutrients needed for optimal milk production. On average, they consume about 3 to 4% of their body weight in dry matter daily, meaning a 600-kilogram adult cow may eat up to 20 to 25 kilograms of feed, along with 80 to 120 liters of water to support milk secretion. Once nutrition is secured, the next crucial factor in producing high-quality milk is ensuring the health and comfort of the cows. Many farms even install roller-style massage brushes. When a cow approaches, the brush automatically rotates, cleaning off dust while relaxing muscles and improving blood circulation. Some facilities go further by playing classical or soft music in the barns, creating a calm environment that reduces stress and helps boost milk yield. And as the herd grows, the precise data recorded by electronic chips attached to their ears or collars also helps farmers determine the optimal time for breeding, ensuring successful reproduction and sustaining the herd's productivity. After a period of careful care, the mother cows enter the reproductive stage. Pregnancy lasts about 9 months, and immediately after giving birth, the cow begins a lactation cycle that typically lasts 10 to 12 months. Depending on gender, the calf's journey will take 2 different paths. Male calves are not needed in milk production, so they are usually sold to beef farms, or in many cases slaughtered early to serve the production of premium products such as veal and Parmesan cheese. Famous as an animal full of emotions, the mother cow, when separated from her calf, often runs after it and calls out until she is exhausted and can no longer continue. Meanwhile, female calves are kept and carefully raised to continue maintaining the life cycle of the dairy herd. From the moment a cow gives birth, it officially enters a crucial stage: milking. When milking time comes, the cows are guided into an automatic milking station, where the process takes place smoothly and without stress. Before milking, the udder is carefully cleaned with a disinfectant solution to ensure milk quality. Then, the automatic milking system gently attaches to the udder, simulating the natural suckling motion of a calf. Each cow can produce around 25 to 30 liters of milk per day. On large farms, total daily output can exceed 50,000 liters, enough to fill a small swimming pool. Immediately after being collected, fresh milk is rapidly cooled to about 2 degrees Celsius to 4 degrees Celsius to maintain freshness and prevent bacterial growth. It is then pumped into specialized refrigerated tanker trucks, designed to keep the milk at the ideal temperature throughout transportation to the factory. From there, the milk begins its transformation into the sweet, creamy condensed milk we all love. But that is a story for the next part. As soon as the milk arrives at the factory, it undergoes a strict quality control process. Technicians carefully measure fat and protein levels, check freshness, and conduct tests to detect bacteria or impurities. Every batch is examined with high precision to ensure that only those meeting the highest quality standards proceed to production. If any issue is detected, the entire batch is immediately discarded to maintain the product's quality and safety. After passing all quality checks, the milk is pumped into the factory's closed processing system for pasteurization, a crucial step that eliminates harmful bacteria while preserving the milk's natural nutrients, flavor, and color. The milk is rapidly heated to about 135 degrees to 150 degrees for 2 to 5 seconds, then quickly cooled. This flash heating method effectively destroys bacteria while maintaining the fresh taste and nutritional value of the milk. Next, the milk enters the cream separation stage, where it is pumped into high-speed centrifuges spinning at 10,000 to 20,000 revolutions per minute. The powerful centrifugal force quickly separates the cream milk fat from the skim milk. This process lasts about 2 to 5 minutes, and the fat content can be adjusted according to the desired production formula. The separated cream is then used to make butter or cream, while the standardized milk continues on to the next stage of production. After cream separation, sugar is added to the milk, and the mixture is transferred into a vacuum evaporator to remove about 60% of its water content. If the evaporation happens too quickly or at too high a temperature, the milk can curdle, caramelize, and lose its original flavor. While if it is too slow, the milk will not reach the desired consistency and may be prone to bacterial contamination. That is why the entire process is carefully monitored, maintained at a temperature of 60 degrees Celsius to 80 degrees Celsius for about 30 minutes to 1 hour, to yield a smooth, sweet, and nutrient-rich condensed milk. But the sweet journey of these fresh drops of milk does not end there. Part of the milk is diverted for powdered milk production, while the rest continues its path to become the sweetened condensed milk we know today. To produce milk powder, the condensed milk is fed into a spray dryer where it is exposed to temperatures of 150 degrees Celsius to 200 Celsius for 30 to 60 minutes. The high heat removes the remaining water, transforming the milk into a fine powder. After drying, the powder is cooled for about 30 minutes to stabilize its structure and prevent clumping. To create sweetened condensed milk, concentrated milk is mixed with sugar at a ratio of 40% to 50%. In some factories, instead of using fresh concentrated milk, reconstituted milk powder may be used as the main ingredient. Regardless of the source, the production process always ensures that the final product has a consistent flavor and texture. The milk and sugar mixture is transferred into massive industrial mixing tanks, where agitators continuously operate to completely dissolve the sugar and prevent crystallization during storage. After pasteurization, the condensed milk is rapidly cooled to about 15 degrees Celsius to 20 degrees Celsius, using a modern cooling system with chilled pipes and convection fans. This quick cooling process helps stabilize the texture, preventing separation or crystallization during storage. Precise temperature control at this stage is the key to achieving the perfect, smooth consistency. Before reaching the final stage, condensed milk must go through a homogenizer, where it is subjected to high pressure of 150 to 250 bar, breaking down fat molecules into ultra-fine particles. This process prevents separation or clumping during storage, resulting in a final product with a uniform texture, smooth consistency, and rich, creamy flavor. After completing all processing steps, the condensed milk is transferred to a modern automatic packaging line. Specialized filling machines precisely measure and dispense the product into each can or container with exact weight. The packaging is sterilized beforehand to ensure absolute safety. Next, the cans are hermetically sealed using heat or pressure, creating an airtight barrier that prevents bacterial contamination and extends shelf life. To guarantee maximum safety, the sealed cans are then placed in a high-pressure autoclave, where they are sterilized with hot steam at elevated temperature and pressure. This step eliminates any remaining bacteria, allowing condensed milk to be stored for over a year without refrigeration. Finally, the cans are automatically labeled with full information on ingredients, nutritional value, and production date. The finished products are packed into cartons or stacked on pallets via conveyor systems, ready for distribution across the globe. Now imagine yourself standing in the middle of a sugarcane field that stretches all the way to the horizon, where towering, sturdy stalks reach up under the sun. Welcome to Brazil, the kingdom of sugarcane. Every year, this country grows over 700 million tons of sugarcane, more than anywhere else on Earth. But don't let the plant's humble appearance fool you. From this seemingly simple grass, humans have built a massive industry worth over $40 billion. And here's a sweet little fact you might not know. Just 10 sugarcane stalks are enough to produce a 1 kilogram bag of sugar. Compared to other crops like corn, wheat, or fruits, which contain less than 10% sugar, sugarcane stands out with a natural sugar content of up to 16%, making it one of the sweetest and most efficient raw materials for sugar production. And it all begins with the harvest season, when the sugarcane fields come alive, ready to kick off a brand new production cycle. Before the harvest season officially begins, farmers in many sugarcane growing regions choose to burn the fields. It might sound unusual, but the goal is to remove the dry leaves and unnecessary tops of the sugarcane. This practice helps clean the stalks, reducing the amount of unwanted material like fallen leaves, organic debris, and insects, which in turn makes the harvesting process quicker and more efficient. Plus, collecting only the sugar-rich stalks helps cut down on transportation costs. However, because this method produces a significant amount of smoke and harmful emissions, sugarcane burning is now strictly regulated. In some areas where it's still allowed, burning must follow specific timeframes and environmental conditions to minimize its impact on air quality and public health. In light of these concerns, harvesting fresh, unburned sugarcane using modern machinery is increasingly being encouraged and is quickly becoming the new standard. Sugarcane harvesters are engineered with high precision, capable of cutting close to the ground without damaging the roots, allowing the plant to regenerate for future harvests. As the machine moves along the rows, a system of sharp, continuously rotating blades slices the cane stalks cleanly. At the same time, the leaves and tops are removed directly on board using a smart separation system combined with powerful fans. These unwanted parts are returned to the field, forming a natural mulch layer that helps retain soil moisture and boosts fertility. The valuable cane stalks, rich in sugar and economic value, are pre-processed on the spot, cut into short segments, and sent to a large holding chamber at the back of the machine. A modern harvester can handle between 80 to 120 tons of sugarcane per hour, equivalent to the workload of dozens of manual laborers. This significantly speeds up the harvest process, cuts costs, and is especially well suited for large-scale sugarcane farms. Once full, the chopped cane is swiftly transferred to waiting trucks at the edge of the field, ready to be transported straight to the factory. This ensures the cane remains fresh and retains its optimal sugar content. After harvesting, millions of tons of sugarcane are transported to the factory by truck or train, depending on the region. The cane must be delivered to the mill as quickly as possible to prevent dehydration and loss of sweetness. Juice samples from different farms are collected separately and analyzed in on-site laboratories to determine the sugar content of each batch. Before processing begins, the sugarcane is passed through a high-pressure water spray system to be thoroughly washed. This step removes soil, sand, dust, and any remaining impurities clinging to the cane stalks, ensuring the raw material meets the necessary cleanliness standards. Thorough cleaning not only protects the crushing equipment from damage, but also plays a crucial role in preserving the quality of the raw sugarcane juice, the primary ingredient used to produce sugar. After being washed, the long sugarcane stalks are fed into specialized cutting machines to be chopped into smaller pieces. The stalks are cut into short segments to make them easier to feed into the crushing system. On its way to the crushing machine, each cane stalk passes through a set of interlocking metal gears that tear it apart. With a processing speed of up to 30 tons an hour, this system keeps the factory buzzing non-stop. If you still can't picture how much that is, one dairy cow would need around 40 days to chew through that much sugarcane, assuming she doesn't get bored and wander off halfway through. Next, these pieces pass through powerful crushers equipped with heavy rollers that continuously press and squeeze the cane to extract raw juice. Thanks to this roller system, the sugar content is extracted as efficiently as possible, maximizing the output of the entire process. Once the crushing is done, the leftover dry pulp, known as bagasse, is far from waste. Instead, it's smartly collected and reused. Meanwhile, the raw cane juice becomes the key ingredient for the next stages of refined sugar production. Have you ever experienced the scent of a mountain of sugarcane pulp filling the air? I bet it's one of the sweetest and most soothing smells that could ever make you feel truly satisfied in life. And now, prepare to be amazed by how factories make almost full use of sugarcane bagasse, turning it into eco-friendly products like plates, cups, and even paper. The bagasse is then collected and transported to specialized recycling facilities by truck or through a centralized transfer system. At the recycling plant, the bagasse goes through a high-pressure water washing system to remove impurities like soil, sand, shredded cane peel, and any remaining sugar. After washing, it is either mechanically pressed or lightly dried to prepare it for the grinding stage. Once cleaned, the bagasse is fed into grinding machines to break down its fibrous structure. The resulting mixture is then cooked at high temperatures, sometimes with a small amount of natural additives like starch or recycled paper pulp to enhance the material's stickiness and flexibility. The processed bagasse pulp is poured into pre-designed heated metal molds, shaped like plates, cups, bowls, or food containers. Here, the hot pressing process takes place at temperatures ranging from 160 to 200 degrees Celsius. Under the combined effect of heat and pressure, the pulp gradually hardens and takes the shape of the mold, while any remaining moisture is evaporated. As a result, the product not only forms a fixed shape, but also gains a stable, firm surface, ready for the next finishing steps. After molding, the semi-finished products go through a final drying stage to reduce moisture content to below 8%. Next comes the finishing stage, where excess edges are trimmed and the rims are smoothed to ensure both visual appeal and safe use. Finally, a water-resistant coating made from bio-based materials or plant-based wax is sprayed onto the surface, allowing the product to safely hold hot or liquid foods. The finished products undergo quality inspection and are then packaged using paper or cardboard materials to minimize environmental impact. From there, these bagasse-based plates, cups, and containers make their way to supermarkets, food stores, or restaurants. In reality, products made from sugarcane bagasse can biodegrade within 60 to 90 days and are considered a much more environmentally friendly option compared to plastic, which takes 500 to 1,000 years to decompose and is one of the biggest environmental challenges today. But the issue is, bagasse products require proper industrial composting conditions to decompose that quickly. If they are thrown into regular landfills, the decomposition time can sometimes be even longer. And now, let's dive into the most anticipated part, the sugar factory, where those sweet drops of sugarcane juice are transformed into the pure white sugar crystals we use every day. After crushing, the raw sugarcane juice still contains fine impurities like fibers, dust, and organic residue. To purify it, lime is added to the juice. The lime reacts with the impurities, causing them to precipitate out, making the juice clearer, a crucial step before concentration. Next, the juice enters a multi-effect evaporation system, typically made up of 3 to 5 connected evaporators. In this system, water is gradually removed by heating the juice at temperatures ranging from 70 to 150 degrees Celsius, depending on each stage and the pressure inside. Through this process, the juice thickens and turns into a pale yellow syrup with a noticeably denser consistency. This concentrated syrup sets the stage for the crystallization step, where sweet crystals begin to form from the thick golden liquid. To begin the crystallization process, seed sugar crystals are added to the concentrated syrup, which is then slowly cooled. Over several hours, sugar gradually begins to crystallize. The resulting mixture is then transferred to a centrifuge, which spins at high speed to separate the sugar crystals from the remaining molasses. This is the key step that defines the difference between raw brown sugar and refined white sugar. A question many people have long wondered about. Brown sugar retains about 3 to 5% of natural molasses, giving it a rich brown color and a distinctive caramel-like aroma, while white sugar is refined to the point that it contains up to 99.9% pure sucrose, resulting in its bright appearance and clean, pure sweetness. After centrifugation, the sugar crystals are still slightly moist, so they are sent into a drying system to remove all remaining moisture. This prevents clumping and extends shelf life. Once dried, the sugar is ready to move on to the refining stage, where it will be purified to achieve its final sparkling white form. To produce pure white sugar, a decolorization process is carried out. First, raw refined sugar is dissolved in hot water at around 80 degrees Celsius. The solution is then heated and filtered through layers of sand and gravel, followed by activated carbon columns to remove the color. Finally, the solution is centrifuged once more to obtain pure white sugar crystals. Once the pure white sugar crystals are obtained, they are cooled and fed into a fully automated packaging line within a sealed, hygienic environment. The first step is precise weighing. Electronic scales measure out exact portions based on preset weights. Next, the sugar is dispensed into preformed plastic bags. These bags are pulled continuously from large PE film rolls cut to size and sealed with heat. This process is incredibly fast. Dozens to hundreds of bags can be packed every minute. After sealing, the bags pass through a metal detector to ensure no foreign objects are present. Once approved, the bags are printed with expiration dates and traceability codes, then packed into large cardboard boxes for distribution to the market. In the late 18th century, as the Industrial Revolution exploded in Britain, the genius of Eli Whitney and his invention of the cotton gin in 1793 turned cotton into the catalyst for sweeping transformations, launching a textile industry now worth over $100 billion. Today, India harvests more cotton than any other country, with over 6 million tons annually. But in terms of yield and exports, the true powerhouse is the United States, thanks to full mechanization and highly optimized farming systems. Meanwhile, despite global controversies over Xinjiang cotton and human rights issues, China still dominates the processing stage, operating the largest textile industry in the world. So what is the real reason the whole world craves cotton so much? Compared to synthetic fibers like polyester or nylon, cotton stands out with its superior breathability and the ability to absorb up to 27 times its own weight in moisture while remaining gentle on the skin, making it the top choice for brands like Calvin Klein, Levi Strauss, and Ralph Lauren. One remarkable fact is that although cotton is among the most water-intensive crops, it is also extremely sensitive and vulnerable to attacks from bollworms, aphids, and thrips, causing the industry to consume up to 16% of the world's pesticides, even though cotton cultivation covers only about 2.5% of global agricultural land. And like every great story, This journey also begins with something small. At this point, billions of bolls simultaneously burst open, revealing fluffy white fibers clinging to the branches like tiny clouds, marking the arrival of harvest season, usually around September to November. Across vast fields blanketed in white, massive round module cotton pickers slowly roll into action. As the machine's harvesting heads, with dozens of rotating spindles lined with fine metal teeth, glide through rows of cotton plants standing about 1 to 1.2 meters tall, they skillfully pull the fluffy cotton from the bolls while leaving the stalks intact. After the harvested cotton is sucked into the machine through large intake ducts, it is fed into a compression chamber at the rear. Instead of collecting loose cotton and transporting it to a separate facility for baling like traditional methods, modern harvesters compress the cotton directly into giant round modules about 2.4 meters in diameter, wrapping each one in plastic film to protect it from moisture. When freshly formed, each roll can weigh up to 4.5 tons, including cotton fibers, seeds, plant debris, and moisture. After compaction and moisture stabilization, the average weight reduces to around 2.2 to 2.5 tons, greatly simplifying transportation and post-harvest handling compared to older methods. Beyond the United States, in countries like Egypt, Greece, Peru, and parts of India, there's another premium cotton variety you may have never heard of: extra-long staple cotton. This type of cotton produces fibers that are finer, longer, and significantly stronger than regular varieties like BT cotton. Because of its high fiber value, ELS cotton is carefully hand-picked instead of machine-harvested to prevent damaging the delicate premium fibers. Surprisingly, due to its price being 2 to 3 times higher than regular cotton, it's estimated that up to 95% of products labeled as Egyptian or Greek cotton on the market today are actually counterfeit. Once the harvest is complete, specialized loaders lift the cotton modules and stack them onto long-haul trucks, some over 12 meters long, which, when fully loaded, head straight to the processing plant, carrying the freshly harvested cotton rolls. This marks the beginning of a new chapter, where raw cotton enters the giant stomach of the textile industry, embarking on its transformation journey into yarn and fabric, ready to fuel the global fashion supply chain. At the processing plant, the cotton modules are unloaded from the trucks and neatly arranged in long, orderly rows at the staging area outside the production zone. This is the first step in preparing the raw material before it enters the industrial spinning process. Next, specialized cotton module feeders begin moving along the stacked rows. Using a rear-mounted hydraulic system, each machine continuously lifts 5 to 6 round cotton modules at a time, or large rectangular bales, depending on the harvesting method used in the field. At many modern factories, once the cotton modules are transferred to the intake zone, they are further processed by a specialized bale opener, a machine designed to fully automate the unpacking process. The equipment gently secures each module in place, then uses twin clamps to carefully peel away the protective plastic wrap, allowing the entire cotton mass to drop onto a conveyor belt, leading to the feeding chute. However, at smaller facilities or in semi-automated operations, workers still rely on a manual-assisted method, using ropes or hooks to gradually remove the plastic wrap before feeding the raw cotton into the processing system. No matter which method is used, once the tightly compressed cotton modules are unpacked, they burst open into a chaotic mass, clumps of tangled fibers stuck together in dense chunks. Therefore, the first step in processing is to loosen the fibers, returning them to a fluffy, free-flowing state for easier handling in the next stages. The opening machine, known as a hopper feeder, uses rotating drums combined with toothed beaters to comb and pull apart the layers of cotton, helping the fibers no longer clump together, untangling the mess without needing a comb. The next stage is primary cleaning, where the cotton passes through large trash removal machines designed to eliminate remaining coarse impurities. These devices use rotating drums fitted with comb-like teeth, combined with powerful suction systems, to extract debris such as soil clumps, seed husks, dead leaves, and fine dust particles. A strong countercurrent airflow works alongside mechanical agitation, effectively loosening and separating light waste materials and channeling them into a dedicated collection system. As a result, a cleaner stream of white cotton moves forward to the most critical phase of the process, separating the fibers from the seeds. This is the heart of the entire cotton processing line, the moment when fibers are completely separated from the seeds. Modern cotton gins use hundreds of small, high-speed circular saw blades that rotate rapidly. As the cotton passes through the machine, these saw teeth pull the fibers through narrow slots, while the larger cotton seeds are too big to pass and remain behind. It's important to note that only about 35% of the cotton's weight is usable fiber for spinning, while the remaining 65% consists of cotton seeds and other impurities. Millions of tons of these byproducts are not wasted. The separated cotton seeds are conveyed along the processing line and stored in large silos or dedicated warehouses, ensuring stable preservation before being processed into cooking oil, livestock feed, or planting seeds for the next season. Cottonseed oil has a light, neutral flavor and a high smoke point, making it ideal for frying and food processing. It is also richer in unsaturated fats compared to many other cooking oils, such as palm oil or lard, which makes it a popular choice in the snack food industry and commercial kitchens. After the seeds are removed, the cotton fibers move on to the lint cleaner, a specialized machine designed for deep cleaning and fiber refinement. This system uses multiple layers of rotating cylinders, serrated bars, and high-powered suction to eliminate any remaining impurities, such as fine dust, small seed fragments, and short, undesirable fibers. After cleaning, the cotton fibers are compressed into large bales using powerful hydraulic presses, packing each block of cotton into standard-sized molds with a weight of about 220 to 230 kilograms per bale. This time, the cotton is no longer pressed into round modules as before, but into compact rectangular bales, making storage, stacking, and transportation in factories much neater and more efficient. A critical step after baling is sample testing, not only to prevent commercial fraud, but also to help textile mills proactively manage risks related to raw material origins, especially as Xinjiang cotton faces strict global scrutiny. After grading and classification, the bales are neatly stacked in specialized storage warehouses, where humidity and temperature are carefully controlled to preserve quality. Once orders are placed by spinning mills, the cotton bales are loaded onto transport trucks and dispatched from the factory, completing the journey from raw field harvested material to a clean, uniform, and standardized product ready for the next phase of textile production. Compressed cotton bales are first arranged in long rows. An automatic bale opener runs along these rows, using rotating spikes or cutting rollers to gently shave off thin layers from the surface of each bale. The loosened cotton is then sucked up through an air duct system and transported to the pre-opener machine. Here, internal blades and spiral rollers continue to break down the cotton clumps into smaller tufts, while large impurities, such as dry leaves, seed husks, and dirt are removed through reverse airflow and filtering sieves. All the loosened cotton is then sent to the blending machine. This is a critical step to ensure uniformity in color, fiber length, and quality because the mill often mixes multiple batches of cotton, including virgin cotton, recycled fibers, or synthetic blends. This thorough blending process guarantees that the yarn produced later will remain stable and consistent throughout mass production. After the opening and blending process is complete, the soft, fluffy cotton moves on to the carding system, marking the official beginning of industrial spinning. The carding machine uses a series of fast-rotating rollers covered with fine metallic teeth to untangle, straighten, and clean the fibers. As the cotton passes through, these rollers meticulously separate the clumped fibers, aligning them into a smooth, continuous stream known as sliver. This sliver is a soft, uniform ribbon of fibers, ready for the next stages of spinning. Next, the slivers are fed into the drawing frame. In this stage, multiple slivers are combined and simultaneously stretched using a series of rollers that rotate at gradually increasing speeds. This process evens out the thickness and length of the fibers, ensuring a more uniform and parallel arrangement. Drawing not only refines the fiber alignment, but also controls the fiber density along each meter of the sliver. It serves as the foundation for the precision spinning process that follows, guaranteeing consistent quality in the final yarn. At this stage, the cotton fibers are further drawn into finer strands using the roving frame. During this process, the fibers are stretched once more while being given a slight twist to stabilize their structure and prevent breakage. The rovings are then fed into the main spinning machine, which can be either ring spinning or open-end spinning, depending on the type of yarn required. Here, the fibers are drawn out to an even finer diameter and tightly twisted to enhance mechanical strength. Depending on the intended application, the finished yarn can have various properties, ranging from soft and smooth to durable, glossy, or elastic, tailored to meet specific product requirements. After the yarn is fully spun, it is wound onto paper or plastic tubes, known as bobbins. Each bobbin can hold anywhere from 2,000 to 5,000 meters of yarn, depending on the thickness and type of yarn being produced. These bobbins are then passed through a final quality inspection machine, which automatically detects and removes defective sections, such as uneven yarn, weak spots, or foreign particles. This step ensures that only high-quality, consistent yarn moves forward to the weaving or knitting process. After the cotton yarn has been spun and wound onto bobbins, it moves to the fabric weaving stage. First, the yarn is fed into a warping machine, where thousands of longitudinal threads are arranged in parallel onto a large spool called the warp beam. This beam serves as the structural foundation for the fabric. Next, the entire warp beam is installed on the loom. Depending on the type of fabric being produced, the process may use a traditional weaving loom or a knitting machine. During weaving, the loom continuously interlaces the horizontal threads through the vertical threads, creating a tightly woven fabric structure. This process transforms individual yarns into large sheets of fabric, with variations in strength, elasticity, and thickness depending on the chosen weaving pattern and fabric design. Once the raw fabric is complete, the dyeing process begins. The fabric is placed into large dye baths or continuous dyeing machines, where color penetrates deeply into each fiber with the help of controlled temperature and specialized dye chemicals. This process can take anywhere from a few hours to an entire day, depending on the required color fastness and fabric type. After dyeing, the fabric is thoroughly washed to remove excess dyes and residual chemicals. It is then dried and fed into a stenter machine, which stretches and fixes the fabric to its precise dimensions, ensuring uniform width and consistent shape for the final product. Before leaving the factory, the finished fabric undergoes a final quality inspection to detect even the smallest defects in color, texture, or weaving before being sent to garment factories, where it will be transformed into billions of everyday consumer products. The problem is, alongside the massive production of cotton-based products, the world is also discarding an estimated 70 to 80 million tons of cotton waste every year. Yet less than 1% of that is actually recycled into new products. Most of it ends up in landfills, gets incinerated, or is exported to developing countries under the label of second-hand goods or aid donations, creating serious environmental and social consequences. This raises not only concerns about the sustainability of the textile industry, but also forces us to rethink our current consumption model. How long can we keep producing and discarding at this pace? After being rolled up, the raw flax fibers are stored and later transported to weaving mills, the next stop on their journey to becoming finished linen fabric. Upon arrival at the weaving mill, the raw flax fiber rolls are sent to the combing area, where the fiber bundles are further disentangled and refined. Here, the combing machine features multiple rotating rollers embedded with fine metal pins or brushes. As the fibers pass through, these pins stretch, straighten, and remove short or excess fibers, leaving behind only the long, smooth, and uniform strands, essential for producing high-quality yarn. The result is a series of smooth, parallel fiber bundles known as slivers. The slivers are then fed into a parallel drawing machine, where they are combined and stretched repeatedly to ensure consistent length and density. During this process, the fibers pass through successive sets of rollers, with each pair rotating faster than the previous one. This controlled stretching makes the slivers finer without breaking them. After 2 to 3 rounds of drawing, the fibers reach the desired fineness and uniformity needed for the actual spinning phase. This next step is crucial for transforming the delicate slivers into true flax yarn. Inside the spinning machine, each sliver is passed through a system of rollers and spindles that simultaneously stretch and twist the fibers. The level of twist is carefully adjusted depending on the desired yarn type. Tighter twists for fine, high-end fabrics, and looser twists for thicker, splied but more robust textiles. Finally, the finished yarn is wound onto bobbins or spools, ready for weaving. Depending on the product design, the flax yarn may be dyed before weaving. In the dyeing room, yarn spools are placed into rotary dyeing vats, where dye solutions are circulated and thoroughly absorbed into each fiber. This process requires precise control of temperature, pH, and timing to ensure even, long-lasting color that won't fade after washing. Once the flax yarn is fully prepared, it moves on to the weaving machines, where the actual construction of fabric begins. Warp threads are aligned parallel and stretched tightly across the loom, while weft threads are inserted back and forth using a shuttle, needle, or airjet system, depending on the type of loom. With each weave, the loom lifts and lowers the warp threads in a programmed sequence to form patterns, while the reed beats the weft into place, producing a strong, cohesive fabric. Modern weaving speeds can reach 500 to 800 picks per minute, generating dozens of meters of fabric every hour. After weaving, the linen fabric is inspected for defects, then rolled and sent to finishing stages such as washing, softening, drying, cutting, pressing, and packaging, ready for the market.